Let's work on the problem 5.9e. The signal is given as 4 sine 50t times u of t minus u of t minus 2. There are two different ways to do it. We can change u of t minus u of t minus 2 to rectangular signal, or we can just keep it as a u of t and u of t minus 2 and use the Fourier transform. So first, let's say we are just using u of t and u of t minus 2. From the pair in the table 5.1 and 5.2, we know 4 sine 50t is a pair with, for the Fourier transform, the 4 pi over j and the delta omega minus 50 minus omega plus 50. And also we have a pair u of t as pi delta omega plus 1 over j omega. Then using time transformation property, u of t minus 2, then that'll be pi delta omega, then e to the negative j2 omega plus 1 over j omega e to the negative j2 omega. If we multiply delta function into any given signal, what's going to happen is it's going to be just delta pi times delta omega, because we're going to let inside of the parenthesis equal to 0, which is omega equals to 0, and plug it in here. Then e to the negative j2 times 0. E to the 0 is 1, so that's that, plus 1 over j omega e to the negative j2 omega. So we'll use these three. So now I have two different signals multiplying t domain that will give us in w omega domain. We have x of w, that is 1 over 2 pi, and then 4 sine 50t, that is 4 pi over j delta omega minus 50 minus delta omega plus 50, convolution of u of t pi delta omega plus 1 over j omega, and minus u of t minus pi delta omega minus 1 over j omega e to the negative j2 omega. So we can cancel this out, and then what we're going to do here, we're going to do this convolution of this convolution of this, and then similar way. So basically we're going to do FOIL convolution. Then this equals 4 pi over 2 pi, that will give us 2, so 2 over j. We have a delta omega minus 50 convolution of 1 over j omega plus 2 over j delta omega minus 50 convolution of negative 1 over j omega e to the negative j2 omega minus 2 over j delta omega plus 50 convolution of 1 over j omega, and then minus 2 over j delta omega plus 50 convolution of negative 1 over j omega e to the negative j2 omega. Now let's do the convolution. When we do the convolution of the delta function, we said this whole thing is going to go in omega, this whole thing is going to go into omega and here. So if we do 2 over j 1 over j omega minus 50 plus 2 over j negative 1 over j omega minus 50 e to the negative j2 omega minus 50, and minus 2 over j times 1 over j 1 over omega plus 50, and then minus minus plus 2 over j times 1 over omega plus 50 e to the negative j2 omega plus 50. J times j squared equals to negative 1, so we're going to apply that. The first term, then we have negative 2 over omega minus 50. Then the second term is going to be plus, because j squared is a negative 1. We have a negative in the numerator, so 2 over omega minus 50 e to the negative j2 omega minus 50. J squared is a negative 1. We have a negative in front, so it's going to be positive 2 over omega plus 50 minus, because the j squared, 2 over omega plus 50 e to the negative j2 omega plus 50. Let's factor out negative 2 over omega 50. So negative 2 over omega minus 50. Then we have a 1 minus e to the negative j2 omega minus 50. If you factor out positive 2 over omega plus 50, we have a 1 minus e to the negative j2 omega plus 50. In order to fit this into sine or cosine form, what we can do, we can factor out e to the negative j omega minus 50.
Hey, Dr. Kim, how do we know we want to factor out?
I mean, at this point from here, this is the decent simplified answer. However, I may say your answer should be in terms of sinc function, then you need to do further. The first thing you want to do is j2 omega minus 50, and then I have only one, the first term. So if you factor out negative j omega minus 50, what's going to happen? The first term is going to be positive j omega minus 50. And then second one is e to the negative j omega minus 50. So now we have a positive j minus negative j. So this is going to give us the sine term. Similarly, we're going to do 2 over omega plus 50. Take out e to the negative j omega plus 50 out. Then we have e to the positive j omega plus 50 minus e to the negative j omega plus 50. Now we need to multiply j2 for the denominator, then we need to multiply j2 to the numerator. So we're going to multiply j2 here so that we have this whole term is going to be the sine term. So if we do, we have negative j4 times e to the negative j omega minus 50 times 1 over omega minus 50 times sine omega minus 50 plus j4 times e to the negative j omega plus 50 times 1 over omega plus 50, then sine omega plus 50. Now combining these two, we'll have the sinc negative j4 e to the negative j omega minus 50 sinc omega minus 50 plus j4 e to the negative j omega plus 50 times sinc omega plus 50. That is the simplest form we can get. Now I'm going to write the problem again. This time we're going to use rectangular signal form. So when we graph u of t, we have u of t, and then when we graph u of t minus 2, and if you subtract it, this portion is going to go away. So that is this. Now we know the rectangular pulse t over t, negative t over 2, positive t over 2, this is 1. Then we can have rectangular t over 2, because big T now is a 2. So we're going to have negative 1 and 1. And when we compare with this, we need to shift this rect t over 2 to the right by 1. So that means we have rect t minus 1 over 2. That is this. So this u of t minus 2 is rect t minus 1 over 2. If we rewrite signal, then we have 4 sine 50t rect t minus 1 over 2. Now we know for sine 50t, the Fourier transform of that is 4 pi over j delta omega minus 50 minus delta omega plus 50. We have rect t over big T, that is from the table, that'll be big T sinc omega big T over 2. Then rect t minus 1 over 2. So when you compare these two, we know big T equals to 2. For the t minus 1, we can use time transformation. Then big T, which is 2, sinc big T over 2, 2 over 2, which is 1, so it's just omega. And then t minus 1, we have to have an e to the negative j omega. In this case, a equals to 1, so it's just negative j omega. Now, if we do x of omega, that is 1 over 2 pi, and then first signal convolution of the second signal. So the first signal, 4 pi over j, and delta omega minus 50 minus delta omega plus 50. Convolution of the second signal, 2 sinc omega e to the negative j omega. Similarly, what we did in the previous exercise, we're going to do this convolution and then this convolution. And then 4 pi over 2 pi, which is 2. Then we have a 2 over j delta omega minus 50 convolution of 2 sinc omega e to the negative j omega minus 2 over j delta omega plus 50 convolution of 2 sinc omega e to the negative j omega. We're gonna capture whole inside of the parenthesis of the delta signal and put it into wherever we see omega. So 2 over j times 2 times sinc omega minus 50 e to the negative j omega minus 50 minus 2 over j 2 sinc omega plus 50 e to the negative j omega plus 50. If you take the j numerator, we have negative j4 sinc omega minus 50 e to the negative j omega minus 50 plus j4 sinc omega plus 50 e to the negative j omega plus 50.